Hi, my name is Ashley Rust, and I'm going to talk today about the water quality impacts from the West Fork Complex fire using real-time data to monitor ecosystem health in the Upper Rio Grande. This work was done with the Colorado School of Mines Hydrological Sciences and Engineering program, the Joint Fire Science program, and the Rio Grande Watershed Emergency Action Coordination Team, otherwise known as REACT. The motivation for our work was to work with a local community stakeholder group to investigate the forest fire impacts on water quality, hydrology, and how those would impact aquatic insect and fish populations, looking at the system holistically. The original goal was to work with the reservoir manager and the state to release water from the Rio Grande Reservoir upstream of the fire that could dilute and mitigate any negative water quality effects. Some quick facts about the West Fork Complex fire. The fire was ignited by 3 separate lightning strikes, forming 3 fires which formed the complex. It was Colorado's second largest fire by area. It burned a national forest and wilderness area, so only 1 structure was lost. The fire was in the headwaters of the Rio Grande, just below the Rio Grande Reservoir. Our overarching goals were to monitor long-term changes in recovery from the West Fork Complex fire, investigating the resiliency of the Rio Grande and the impacts on the tributaries. We're using the West Fork Complex fire as a case study for a large-scale Joint Fire Science Program project where we are looking for water quality trends from hundreds of western fires to identify key drivers of short and long-term response and resiliency. To accomplish this, we deployed water quality monitoring probes throughout the Rio Grande headwaters and its tributaries, both above the fire as control and below the fire to catch burn-impacted areas. The water quality data is connected to the state's website, the Colorado Division of Water Resources, and projects data real-time so anyone in the community can check on the status of the water quality. We also monitored total and dissolved metals and nutrients. To look at the whole system, we looked at aquatic macroinvertebrate populations and fish populations by working with the state on sampling. The main water quality impact from the fire has been increased turbidity and total suspended solids due to erosion from burn-impacted hill slopes. The summer rains physically displace soil that is then washed into the streams. The higher sediment levels did not disrupt the trout population in the Rio Grande because the high connectivity of the river, fish are able to avoid areas with poor water quality. However, in the small tributaries, fish were unable to escape, and there have been a few localized fish kills. The summer rain events shown in the upper graph cause erosion, creating high turbidity in the burn-impacted areas, but not in the control area where there is healthy vegetation keeping soils in place. Here is data from one of the fish kills on Trout Creek, where the precipitation event caused elevated total suspended solids, well above trout thresholds of 50 milligrams per liter. We returned to this tributary 1 year later to see how the trout population was doing. We found that the population above the hillside was a typical fish population with a range of fish sizes and ages. However, below the hillside, older, larger fish were absent, likely from the fish kill the year before. The exciting outcome was finding a lot of young fish, showing ecosystem recovery. The original goal was to use the real-time monitoring to help guide reservoir releases. Here's a loading duration curve showing the concentration of total suspended solids and their frequency of flows that correspond with these concentrations. The acute threshold for trout is 50 milligrams per liter. To maintain healthy fish populations, total suspended solids has to remain below this concentration. Dilution releases could help maintain this level of water quality. However, it would require the release of a lot of water, greater than 300 cubic feet per second, which is not feasible under current water management. We plan to continue monitoring water quality impacts and recovery 3 years after the fire. We hope to identify key characteristics of resilient watersheds for future fires.